That is what we have. So from there now we are saying here we need to replace with 5 over 2 since this is our sum. So 5 over 2 squared minus 2 on the product here we replace 7 over 2. So I have 7 over 2 and minus 2. Okay. Then the whole lot of this we're saying over the product here is 7 over 2. 7 over 2 squared minus here we're going to have the sum which is 5 over 2. 5 over 2 squared minus 2 multiplied by the product which is 7 over 2. Then we close n plus 1. This is what we have. Okay, so from there we proceed and say, okay, so 5 over 2 squared, so we're going to have 25 over 4. So this will be 25 over 4. We square what is on top and square what is down. Minus, now this 2 and that 2 will cancel, so we have minus 7. Minus 7, then we have this minus 2 here. Minus 2 over, then 7 over 2 squared. We're going to square the 7 and square the 2. So we're going to have 49 over 4 minus, okay, so we can put our bracket there. So here inside 5 over 2 squared, we're going to have 25 over 4, then minus the 2 and the 2 are going to cancel. We have minus 7, then plus 1. Okay. Then from there now, we're going to say here on top we have 25 over 4 minus 7 minus 2, you get minus 9. Allow me to use this kind of division for this, to simply put the division sign there to represent this whole thing there. So then down there we're going to have 49 over 4. 49 over 4. Then we'll take through the negative. So negative times this, we're going to have minus 25 over 4. Then negative times that, we're going to have plus 7. Okay. Then plus 1. Okay, like that. Okay, so here we can do the common denominator, which is 1. So common denominator is 4 there. So here 7 plus 1 can give us 8. So that we just write one thing here. 7 plus 1, that's 8. So I'm going to have 8 here over 1, since we have to do with fractions. So over 1. So now here we're going to say, okay, 4 into 4, 1. 1 times 25, we have 25. Minus 1 into 4 is 4. 4 times 9. What is 4 times 9? Should be 36, right? If I'm not mistaken. What do we get there? Then the common denominator here is 4. So 4 into 4, 1. 1 times 49, you get 49. Minus 4 into 4, 1. 1 times 25, you get 25. Plus 1 into 4 is it's 4. 4 times 8. What is 4 times 8? Should be 32, right? Yeah, 32. So when we add what is on top here, what do we get? What is 25 minus 36? Negative 11. So you get negative 11 over 4 divided by, what do we get on top there?
Uh, 56 over 4.
So you get 56 over 4. Okay, 56 over 4. So then from there, From there now we have negative 11 over 4 times, we reciprocate this, times 4 over 56. So this and that cancels. So we remain with negative 11 over 56. So this is the value that we get. Any question? Any question?
This one was a little challenging, so there was much to do here.
How many marks did it have, Listen? 7, right?
Yes, 7.
Yeah, so 25 minus 28 over 4. 25 minus 28, that is so that's minus 3 over 4 plus 1, and this becomes plus 3 over 4. Okay, I want to see whether if we are to work out what is inside, we can get something different. So we're going to have 49 over 4 plus 3 over 4 plus 1. So 1 can be 4 over 4. So meaning we have 4, and we have 49 plus 3 plus 4. So 49, 50, 51, 52, 52, 52 plus 4, that will be 56 over 4, which is exactly what we have the other side there. Okay, so that's okay. Yeah, so we are done. This is what we were expected to do. Any question?
Oh, on this one,
Yes.
the rule doesn't apply because
Which rule now? Which rule, Liseli? Which rule?
when you finish calculating, you're supposed to put using this formula x squared minus sum of roots 10
Oh.
plus a product of roots equals 0. Now, I'm only seeing one value. That's the confusion.
No. That one, you are forming an equation. The question was very specific, says form an equation, write an equation. Here it says find the value. Are you getting the difference? This one is saying find the value of 1 over alpha squared minus 1 plus 1 over beta squared minus 1. You're finding the value. So it's different.
They gave us the plus there. We're just finding the value. They already gave us the something plus.
Yes, we are adding those two. But the other one, we are supposed to form an equation. That's why we had that standard equation.
Okay, sir. Thank you.
Yeah, you're welcome. So, yeah, check around. There are so many other questions that you can have here. So let me also find out if you have, do you have avionics April, May 2023? Are you able to find it?
Among the papers you sent, or
Yes, it's there among the papers I sent. There's a question
yes,
there.
but I also wanted to raise concern. You didn't send avionics on Wednesday.
Which one did I send avionics?
You didn't send avionics. You only sent, I think, 2 repeated questions. Some question papers.
No, just check
April and
nicely.
May.
Just check properly. I think I
Yeah,
sent.
I did.
No, just check again. So do you have April, May 2023 avionics? Are you checking?
Yes, sir.
Try to check April, May. April, May, avionics. There's a question I want us to solve there. Still checking?
So you said April, May 2023?
Avionics, yes.
Yes, I've seen it.
You have seen it?
Yes.
Go to question 2B.
Polynomial.
Question 2B.
Oh, an aircraft. Yes, I've seen it, sir.
You have seen question 2B. Are you able to read the first sentence just to confirm?
Okay, let me read it. From what I'm seeing, April, May 2023 avionics, it's saying an aircraft engineer wishes to enclose a rectangular plot.
Good. That's the
the one?
question. That's the one,
Okay.
yes. So it says, this refine that question. It's there. You wanted to accuse me. Thank God I'm defended by Brandon. So we are saying, an aircraft engineer wishes to enclose a rectangular plot for his aircraft engineering workshop using a wire fence on 3 sides and a wall fence on 1 side. If he has approximately 2,400 meters of wire fence, okay, what is the greatest area he can fence off? What is the greatest area he can fence off? So there is a wall fence here. Then he has wire to fence 3 sides, and it has to be something like a rectangle. Something like that. Okay, so it has to be something like that. So now if we have x here, x length from this part to this part, what do you think would be the length the other side there? Yes, if x here is the length this side, what would be the length the other side? Yes, Brandon.
It can also be X.
Good, because for it to be a rectangle, it means these 2 sides must be the same, and these 2 sides also must be the same. So this one is also going to be x. I hope you're able to see the color I'm using, or I change. Are you able to see?
The color is okay.
Sorry?
I think the color is okay.
Okay, great. Yeah, so we have x there. So we have x here, we have x there. Now, the whole wire fence he has is 2,400 meters. If there's x here and there's x here, how much is remaining? So this x plus that x is going to give us 2x. So meaning from this 2,400 meters, we are subtracting the 2x to get the other side. So we're going to have 4 like that minus 2x. So this is the length of the other side which is remaining. Because the total is 2,400 meters. So if we have removed x and another x, so we have 2x. So we subtract 2x from 2,400, then we are going to get, yeah, this is what we're going to have there as the length the other side. So now the question says, what is the greatest area he can fence off? So meaning we need to find the area of a rectangle. So area of a rectangle, what is the formula for area of a rectangle? Area of a rectangle
Is it A is equal to LB squared?
No. LB. Just length times breadth, you get the area. So a square is the one where you have L squared, but for this one is L times B. So that is what we have. So you pick only one length and the breadth. So meaning area is equal to length, which is 2400 minus 2x times x, which is going to be x times 2400, it will be 2400 x minus this times this, we get 2x squared. Okay, so are you seeing a quadratic equation there?
Yes, sir.
Yes. So there's a quadratic equation that has been formed here. Now, the time you are going to do differentiation, if we had done differentiation here, we know that at maximum area, the derivative there of the area is equal to 0. So dA dx at the maximum area should be a 0 here. So if we had done differentiation, we're going to differentiate through and say dA dx is equal to, we differentiate this. When we differentiate, do you still remember how to differentiate? We try to use differentiation, then we can use other formulas, other method later. Do you remember how to differentiate?
No, not exactly, sir.
Please, Sally.
A bit, sir.
A bit.
Yes.
So if we have y is equal to 2x to the power 3, so dy dx is simply, when you are differentiating, you get this power multiplied by the coefficient. So what is 3 times 2? It will be 6. Then you write your x. Now, this power here, after you have multiplied by this to get 6, then you subtract a 1 from there. So it will be 3 minus 1, which will give you a 2. So this is how you differentiate. So that's the derivative there, is simply 6x squared. So here, the power is 1. So when we multiply 1 times 2400, we get 2400 x. Now, since the power is 1, we need to subtract a 1. So 1 minus 1, we get x to the power 0. X to the power 0 is the same as 1. So 1 times 2400, we are simply going to get 2400 here. Okay? Minus 2 times 2, we get 4. X. When we subtract 1 from the 2 there, we just get 1 as the power. So that one remains like that. Now, we are saying if you are finding the maximum area, then dA dx is going to be 0 at the maximum area. So this is going to be 0 is equal to 2400 minus 4x. So this 4x can come the other side, so that we have 4x is equal to 2400. We divide here by 4, divide here by 4. So that cancels. So we're going to have our x is equal to 4 into 24 is 6. So x is equal to 600. So we have established the value of x, which we are saying the value of x is 600. So now if the value of x is 600, then what is the maximum area? So area, we are simply saying area, we are simply saying here where there's x, we need to put 600, or we can come back to the formula for the area here, which is this one here, because it's simply length times breadth. So we're replacing wherever there's x with 600. So this is going to give us area is equal to 2400 times 600 minus 2, then 600 squared. So 2400 times 600, what do we get? Anyone take a calculator? What do we get?
We get 1,440,000.
1,440,000 minus, what is 600 squared then times 2?
$720,000.
720,000. So when you subtract 720,000 from this, what do you get? I guess you get the same 720. Is it so?
Yes, sir, it's correct.
Yeah, so you get the same 720,000 units squared. So this is your area. That is if you are going to use the differentiation method. Okay, so let's try to use another method. Okay, we use another method, so we'll pick it up from here. We'll pick it up from there. So now, the other method we are going to use is, we are going to use completing the square method. Completing the square method. So, completing the square method, so I'm going to say 2,400, rather, we need to start with the what's this, the negative 2, so we're going to have negative 2x squared plus 2,400, 2,400 x, okay, which is our area. Okay, so now here we need to remain with x squared only, so we can factor out the negative 2, so that will remain with x squared. Okay, so this divide by that, we're going to get minus 12 minus 1,200 x. I hope that is okay, because when we multiply this times this, will get back that. This times this, the negative, negative, positive. 2 times 12, it will give us 24. So we have factored it out. We can't divide through by 0 because this is not even equated to 0. So if it's equated to 0, it becomes easier to divide through by 2. But since it's not equated to 0, we better just factor out the 2 outside. Because when you're completing the square, this one has to be, needs to have the coefficient 1. Okay, the coefficient there must be 1. So from there, we are saying this is going to be negative 2. Then we have x squared minus 1,200 x. Then now here we say plus half of this. What is half of this? It's 600 squared, right? 600, isn't it?
Yes, sir.
Squared minus 600 squared. That's how we complete the square. So this is going to be equal to, so we have minus 2. Then here, this whole thing here, you only get this x and the half which you have squared there, which is 600. Then pick the sign in between, This one with x to the power 1 and this one with x squared. The sign in between is the one you use. So we're going to have x minus 600 squared. When you square this, you're going to get back this. Then we're saying minus 600 squared is going to be 36. Is it 36,000? Brandon? Or 300 and is we are going to get 36,000, isn't it?
Yes, sir.
Is that so?
For 600 squared.
Yes. What do we get? Is it 360,000 or 36,000?
It's 360,000.
360,000, right?
Yes.
Yes. So now we can multiply back our -2. So we're going to have -2x minus 600 squared. -2 times this, we're going to negative plus 2 times this, we're going to get what? Is it 720?
Yes, sir.
720,000. That's what we are going to get. Okay, so 720,000. Oh yeah. So now at this point, when you want to find the value of x, this one you need to equate this to 0 to get the value of x, which is going to give us our 600. So when we get our 600, then we can go back and fill it up here in the formula like we did after we found the 600 using the differentiation. Then from there, we go down until we get the answer that is required, just like we did earlier. So here, this part, when we equate it, we get the value of x. Yeah. So any question on that?
No, sir.
Yeah, so if you're asked to solve, let's try to finish it up and equate this to 0. Let's introduce the 0 and see what we get. So from here we can say, okay, let's take this one the other side. So we're going to have -2x minus 600 squared is equal to, this goes the other side, is equal to -720,000. Let's just try and see what it will give us. Yeah, so -2 -2, this and that cancels, so we are going to say equal to x minus 600 squared is equal to, so when we divide this we get 360,000. Okay, 360,000. Then from there we can introduce the square root. So here we're going to have x minus 600 is equal to, when we introduce the square root here, what are we going to get? 600, right?
Yes, sir.
So we're going to get 600. Yeah, so meaning when we take the 600, the other side, x is going to be, this goes the other side, it will add to give us 12,000. Okay, so this is not making sense. Why? Because I said there's no 0 that we are given. So the us equating it to 0, it's something else that we are looking for or what we are dealing with. Yeah, so we can pick it from there. So here, just here you can get the value of x, which you can replace in the formula and be able to work it out. Any question?
No, sir.
I think we are done with quadratics. So what topic can we start tomorrow?
What would you suggest, sir? Because we've covered many topics and we've done matrices. already. What would you suggest? Something that you feel may come that you haven't touched?
Yeah, I expect that to come from you. That's why we are doing topics so that yeah. So you guys, we need to make some agreement. Yeah, we need to make some agreement of some kind, of some sort. The papers that we are doing, I can sacrifice some time and solve one or two papers for you where I solve every question, 1 up to 8. So long we can meet somewhere so that when I sit down to do that, I don't feel like wasting time. From the papers that I gave you, I can solve two, like solving everything so that you are just going through and trying to understand, to say, oh, here, this is that, this is that. Because from what I'm seeing, we may not be able to do every topic like we are doing here. Yeah, but I can solve, and then you are going through where you get stuck, you ask. Where it's clear, you know, oh, this is very clear, this is how you go about it. Where you felt, I can't even start solving this question, I would have started for you, and you just follow along, and then from there, you pick it up.
There's that question that you are about to show us.
Which one? Which one?
One for squaring. If you can help us with that.
Which one, Liseli? I can't
The
remember.
one for quadratic equation squaring. It says not have names.
Kindly switch off your mic. Namakao, switch off your mic. Liseli, switch off your mic. Okay, so Liseli, I don't know what was happening with your mic. Yeah, it was. Yes. No, kindly speak up. I can't get you.
I was charging my phone. So
Even mine is low now. Yes.
So there's that question you were solving last week for quadratic equation. Maybe you can help us with that. Like when you said that you're going to help us with some questions.
Last week.
The one we did squaring, yes.
I can't remember anything.
The whole topic.
I can't remember anything.
There's a question that you saw, you were about to solve. You said it was the whole topic, like the whole question on squaring.
I can't remember.
I'll send it tomorrow.
Yeah, you can send it tomorrow. So what, Brandon, you are saying I should decide what we are doing tomorrow?
Maybe because my suggestion, the topic I want to suggest is quite bulky.
Yeah, and not everything may be necessary.
Yes.
We have done APs, GPs. Have we done polynomials?
No.
Okay, there are some good marks also for under polynomials which you may not need to miss. Yeah, so we need also to just do a few things on that. But then we have big topics like we finished trig, isn't it?
Yes, we did.
Okay, so we may need to do calculus. I think that's we did logs, which is well and good. We did matrices, well and good. I think we have covered quite a lot. So we may need to do calculus, that's integration, differentiation, and also binomial comes. Yeah, there are few papers that don't have binomial. Usually it comes.
So tomorrow we can begin with binomial, then move on to calculus.
Not a problem.
That's fine.
Not a problem. So binomial, it's a simple topic that I can teach and finish in just 1 hour or so, less than an hour, depending on you guys how you'll be understanding. I can teach it in less than an hour. Then we move to questions. Yeah, so we can finish binomial tomorrow. Just tomorrow we can finish it. So the other day we can start calculus. Next week we can finish calculus. The other week I think we should be saying goodbye to each other.
Alright, so that's fine.
Yeah, so I think we can end here for tonight.
Alright, sir. Thank you very much. Good night.
Yeah, have a good night
Thank you,
too.
sir.
All right.